Okay, hi everybody, YouTube world. All right. Oops, I screwed up again. Didn't I do that yesterday? Never mind. Okay. I did, actually, fifth hour did this great. Does anyone know what the word rational means? What does the word rational mean in math, not like in English? We just said whole numbers, integers, so on and so forth. Then rational numbers. Rational numbers are numbers that anyone want to finish? Can be expressed as, can be expressed as a fraction. Sorry if I spit on anyone. All right, you don't remember that? Some people look like they're this is going to be a rough class for them dealing with a guy like me. But that's what this implies. Fractional is what rational. These are synonyms in math. They really are. So what today is all about is dealing with fractional exponents both back and forth. And I'm going to zoom in on this, and I'll show you what you really should write first, and then show you what the other parts really mean, which are good stuff. Okay, what you should write is this. U raised to the m over n power. That is equal to writing this in radical form. This is review, folks. You should at least be saying, oh yeah, I remember this from last year, where the denominator of the exponent is the index of the radical, and the numerator is the power on the number. And then really all that this says is you have a choice. You have a choice of the order that you do this. You could either raise the number to a power, then radical it, or you can radical the number and then raise it to a power. So these are the first three things that are important. What are these other two things then? And I did over-explain it in the other hours so that you understand all the things that you're going to run into today, because a lot of it's going to be some grade school math skills you have to have employed. So what are these two little things here? I'm only going to concentrate on this one, not so much that one. I have a question, and I'll ask that offline. Just discussed on offline, what do you do with a power raised to a power? You multiply them. Well, that's all this shows. This shows this rule pulling like the fractional part of the exponent out through the multiplication rule of exponents. And then what makes me infinitely sad is the high school students don't have a good fractional background. So how do I take m times 1 over n? Well, this is over 1. And by the way, this is u raised to this power. So, but what do I do when I multiply fractions? And the answer to that is you just flat out do what? Multiply across. You are going to have these rules come up so many times from now all the way till May, all the time. And usually what messes people up in cats, meow, is not the cat, it's the grade school. Knowing your fractional rules. So that's why I spend a lot of time going over this stuff, what all those other parts mean. Okay, now we're going to get a student. We already have. You're up, and this is what you have to understand about this one. The first part of your homework tonight is supposed to be done without a calculator. And if I remember the book correctly, I haven't read it in a while, but it does say without a calculator. So this first and second question are no calculator questions. And if I quiz you on this, which I will, you will not have a calculator in your hands at all to do this one. So you better get used to your times tables and know what to do. So what do you do first, student number 11? What you do is you change it into this form. And just because of time, that's why I'm saying that. So what number goes right here? 2. Now that hardly is ever written, but you're sticking it there so you know where the parts go. Then what big number goes right here? And then what number goes right here? 3. So I'm putting, the numbers into places where they belong, and this is just an employment of the rule. The index is the denominator, the numerator is the power on the number. With no calculator, there she goes again. No calculator. Do I expect you to take 16 to the third power? Do you think? Am I that mean? Do I look that ugly? No. What I expect you to do is do this first, knock the number down first, and then build it back up. What's the square root of 16? 4. And then bring down the third. What's 4 to the third? You better get used to this. This number is going to come up a lot. Who knows what 4 to the third is? We have no time. Did you hear them? It's a lot of people that know that number. Perfectly easy without a calculator. Here's the next one. Now, I'm going to give you a chance. I just told the student that got picked that 95 of the students get this wrong because it is tough. They do a common error. I'm just going to tell you, you be my pen. You tell me what to write next, and then I'll tell you if you're right or wrong. And no one can hear you, so don't worry about it. Not yet. Okay, you are actually right. Remember you said that? That's exactly what the last hour student said. She said it's fourth root of. No, you need to take care of something first. I want you to take care of the negative. So that's what I want you to do first. So we did have a hiccup. Okay, first things first. Let's write this down. Put this somewhere. I don't care. Put it close to this example because it has everything to do with it. And if you don't do it, you're behind and you're going to have troubles. And no one answered any questions and could help, so I think everyone needs to do this. X to the third means what? X times, say it, because when you talk, you activate. And then what's x to the fourth? Just go fast. X, 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 all right? Now, how many x's cancel? Say it. 3. How many x's are left over? Say it. But where? In the bottom. So everyone would know by doing this the old-fashioned long way, the answer to this is 1 over x. Okay, but you also learned another rule, and I've actually talked about it today, and it's actually going to come up later, actually. What am I supposed to do with those exponents if I do this the quick way? Starts with an S, I have no time. Subtract. So I could take this and go x to the 3 minus 4. It is always numerator minus denominator in the classic subtract exponent rule. What is 3 minus 4? And then this is all I can tell you. The subtracting of exponent rule created the negative exponent conundrum. See, when you have more exponent on the bottom, that means you have variables or numbers left over in the bottom after canceling the old-fashioned way. So what do mathematicians say? You need to know that. So therefore, x to the negative first equals 1 over x to the positive first. So then a rule is created. Whenever you have a negative exponent, you take this whole chunk and put the whole chunk down on the bottom and just turn the exponent what? Positive. That's it. So I know we have fractional exponents, but nothing happens with the fraction. And as a matter of fact, you never, ever, ever flip an exponent. Ever. Okay? In simplification scenarios. Okay, now we're going to go back to what do we do from here. Now what do we do? Do that thing that you were going to say. 1 over, okay, what goes here? 4, and then what goes here? Good, and then what goes here? And then what do you do first? Cube or fourth root? Now this is a tough question. Do you know the fourth root of 625? Okay, who knows the fourth root of 625? Let's speed track it. It is 5. Okay, so that's 1 over 5. Yes, you better get used to that. That's probably the biggest number we're going to have. Fourth root of 625, just hammer it down, it is 5. All right, and then 5 to the third. You better be able to do this. 5 times 5 is? And then 5 quarters given to the lunch lady or man. 125, so it's 1 over 125. You will be asked to do that without a calculator. Now, in your homework, read your directions. This simply says, write this in exponential form. This is a wax on, wax off. Just do it to get used to the rule. I will help you, student number 25, to make this, not that you needed it, but always in radicals, as long as the indexes are the same, there's only one radical. Think of this at least as the 7th root of and the 7th root of. And then you can do this real fast. What's the answer? So writing it as an exponent means n to the what power times y to the what power? This question is just, do you know how to use the simple rule? I wouldn't say simple, but it's just a rule that you need to be aware of. It's a math notational scenario. I'm going to change the game on this one because, and I'm going to say this online real quick. What time is it? Oh, I'm actually going. All right, so that's good. So we're good. Sure, one answer could be this. 4th root of n to the third times 5th root of y to the first. And this is correct. But then pretend this is a just listen. Pretend this is a multiple choice test. I'm all proud of myself. I go to A, B, C, D, and that's all, and none of those are there. Like, this is not any of the answers. Now there's panic in the streets. Well, look at the answers and try to see, hey, did something else happen? All right, and then I think because we only have 11 minutes, I'm just going to take over. I may bump in and try to get some students here. So, all right, there's something different I can do. And I look at some of the answers, and I notice that there's something that's comparative to these two numbers that they have in common. And I notice some of the answers, there's just one radical. There's not two separate radicals with a different index. There's one radical with the same index, meaning there's an N and a Y underneath it. So with those clues, did I help anyone on what you might be able to do on this? We had student number 21 in 6 hour Get This. You can change any number as long as it's equivalent to the previous. So we could change this so these have a common denominator, because a common denominator would turn into a common index. What is that common denominator? Now, we're not adding these. We're just trying to do a little trick, because I noticed in my multiple choice there was a 20th root. I don't know 4 and 5 have 20 in common as a multiple or a factor. They're a factor of 20, whatever. So legally, I can change this to 15/20ths, and legally, I can change this to 4/20ths. Times? And then times y. Yeah, I just confused it when I said that. I just meant times, like multiply by. Yep. And then you see that that's one of the multiple choice answers. Isn't that wild? Yes, Mr. Samuelus. Online, and you're just going to be, you should listen, all right? A lot of people in the other classes, the other teachers are talking about mindset of the students, and maybe I'll bring that stuff up in my class because it is great stuff. But the one thing about mindset is you don't sit there and do nothing. And I know that was a double negative. But you don't sit at a question and say, I don't know what to do, so I'm just going to skip it. You do something. And the something that you do for this is, okay, what did I just learn, or what did I just get reminded of? And what I got reminded of is, okay, if I work inside out and I attack this at least one step at a time, so I look inside and ignore the fourth root thing, I know I can turn this into n, anyone? N to the 1/5. So that's the inside, working inside out. Now it's the time to go outside. Okay, what does this mean? And what's weird about radicals compared to exponents is, where do these things go? What's the fourth root the same thing as? Raising it to the 1/4 power. And actually, exponents go this way when you go inside out. They go to the right. And now that I've did that, I can actually use an exponent rule. And what does the exponent rule say I can do with these two things? And then lo and behold, at the very beginning of the notes, I taught you how to multiply fractions. And how do you multiply fractions? You just multiply across. And then you're all proud of yourself when you circle that answer, but you forgot the directions. What were the directions? Write this as a single radical. So turning it into an exponent was an attack on the question, at least to get it in the format to answer the question. That's what's going to be tough about your homework tonight. There's different directions and different things that you need to do for those directions. Okay? Okay, and then because of time, I have to take over, take control. This is the same thing as what class? You're alone. And then over, no one does. And then you're supposed to do, oops, sorry. And then what are you supposed to do with these exponents? What are you supposed to do with those exponents? Y over Y. So subtract. You are dividing y over y, but the rule that you learned last year with whole numbers and nice little perfect exponents is subtract. This is cat now. All we're doing is employing some fractional ideas with the same rules that you learned last year. You got to know your fraction rules. When you subtract, you need a what? Common denominator. What is that common denominator? Someone spill it out. 12. So I have to multiply by 4, multiply by 3. And I'm going to leave that there, but then I'm write the final answer. Not the final answer, though. We need one more step. But what's 4 minus 3? 4 minus 3. And then 12, 12, 1 12th. So the final answer is 12th root of y to the first. Now, I don't have time for this because we only have, sorry about that, 4 minutes. Don't be making up a rule for this. Last hour, we came up with another example. I mean, what's 3 times 4? What's 3 times 4, everybody? This is an accident. I can come up with another example that this does not happen. There is no cheating rule on this one. You have to go through this process. Just trust me. I'm on your side. I love you. All right? I would never steer you wrong. Sorry if that makes you uncomfortable that I just said that. All right. Couple more. Here's the problem with this one. These indexes are what? These indexes are not what? They're not the same. So guess what you should do? Even though it doesn't say anything about fractional exponents, to get this to happen, fractional exponents are the key. N to the what power? 1/3. Nice. Some people are just right ninjas, math ninjas. N to the what? 4 over 5. When I multiply two numbers together, I do what with these exponents? When I multiply two numbers of the same base, I add them. And then I'm just going to go ahead and put these fractions there and then ask what's the common denominator. So multiply by 5 and multiply by 3 because you said 15. And then what's this? It's still not there yet, but at least we'll get the next step. What's the power on this n? 5 plus 12 is what? See, I really don't think I should cover this along. This is just grade school. I know it's a fractional rule. I'm sorry, an exponent rule, but it's grade school what I'm doing as far as getting common denominators. Now, here's the issue with this. The question said write as a single radical. Who can tell me what the problem might be when I make this the 15th root, remember, of n to the 17th, and then writing that as a single radical? What might a teacher have an issue with this about? A 15th root, I wish I had what? Something times itself what? 15th root wants something times itself 15 times. So, who comes out? 1n, and then who's left? So 15th root of n squared. Okay, so these last two, sorry, 6th hour, I didn't really get to hit this with you guys, but simplify is the last part of your homework. Please read your directions. So when you get to the section that says simplify, it is a little bit of a pain in the behind. You have some questions that are fractional exponents and some that are radicals. All right, and you have to listen to me on what you need to do. Anything that starts as a fractional exponent, when you simplify, you end up as a fractional exponent. Don't be turning them into radicals. Okay, so just do your exponent rules and then keep them as a fractional exponent. In the simplify section, if it starts off as a radical, just simplify the radical and then be done. So you have to keep it in radical form. Try to do your radical simplification, root it, reduce it, rationalize it, and then leave it as radical form. Don't start messing around with fractional exponents. I know that's confusing because this whole section intervenes or interjects between those two concepts. So what do you do in this first one? This is times, times, times. What you do is remember the commutative property, which is I can reshuffle these and put them together and see them together. And this is not a necessary first step to be written if you understand that. Because you probably would just, if you knew that, understand that the next part is when I take an n times an n, you get a common denominator because you have to add these exponents. That's what happens when you take an n times an n. We've done that a lot today. So 2 plus 18 is 20 over the common denominator 3. Now this is what I mean about if it starts as a fractional exponent, leave it as that, because this has some radical issues that we ran into class today. This is a cube root of n to the 20th. Then you're going to start trying to pull stuff out of that. No, 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 no. Just fractional exponents stay as fractional exponents in this particular section. And then these y's are actually all set up. Y to the 5/3 because there's already is a common denominator. So simplify those directions, just leave it. I know we could do a lot more with this, but just leave it in this section alone. And then this one is, simplify with a radical. So leave it as a radical. So it's always the root it. Well, here you go. This is a perfect fourth root. So I'm going to like that. All right, and then is anything else root? Not really. I could see maybe something with this, but then is there a reduce? And there most certainly is. So these are the first things you need to look at as far as getting this radical ready to be rationalized. So, oh, no, my bad, dogs. What I have to do is make this the fourth root of 16, which is 2. I'm going to do a lot of that. With a fourth root, you can separate this in all separate fourth roots. I'm not going to write all this, and I wouldn't want to do this with the second one anyway. So I'm going to, intervene and do that a lot. You can kind of just fourth root things individually when it's all times across. So the fourth root of 16 is 2, and then n to the 5th over n is n to the 4th up in the top. But I didn't do anything with the radical yet. So this is still the fourth root of. All I did was simplify this. This turns into a 1 on the bottom. And the fourth root of 1 is 1 anyway. So this is just 2 times 1. So that's why the n just disappears. And I don't do anything with that. All right. And then what's the last thing I have to do? The problem is you have rationalized, but you haven't simplified all the way. So the fourth root of n to the 4th is n. The whole idea of what you have to do with radicals. All right, and that's it. Actually, that's all I didn't do with you guys. Blah, blah, blah.